Okay, we have the question, make a table and sketch graphs, the basic exponential function and its inverse function. Most of the class, with some exceptions, didn't know what the basic exponential function was. They thought it was y equals x squared. The basic squaring function. You've got to know the names so that you start sorting the nature of these functions out, because the nature of these functions is central to this course. As I said, if you don't know these things, you're not really in the course yet. Fortunately, all you need is 30 minutes of attention and you can get this straight, okay? You have to give it that attention. You really don't want to be going much further in this course without knowing these things. And then there's the arithmetic of evaluating the basic exponential function, which is y equals 2 to the x, not y equals x squared. Two to the negative 2 means what? 1 over 2 squared. Negative exponent means you take the reciprocal of the absolute of the expression with the absolute value of that exponent. But now we've said this a number of times. If it hasn't taken, you really need to review the rules for exponents. You have to know them all. They're all important, and you can't really function in this course unless you know the rules. Okay? You won't understand the function, you won't understand the behavior of the function, and you won't be prepared for calculus class. Okay, so 2 to the negative 2 is 1 over 2 squared is 1/4. 2 to the negative 1 is 1 over 2 to the 1, which is 1/2. 2 to the 0 equals 1. 2 to the 1 equals 2, of course, and you know that, and 2 squared is 4. I always have trouble in a pre-calculus class with people not knowing their basic arithmetic and being able to deal with fractions. Now, it's not that I have trouble, it's that students have trouble. Okay? You have to get this straight. Okay, so there it is. Those are values. Again, if you did something different, don't erase it. You're right there in your quiz, so I can't stop talking about what you didn't understand, because I need to be able to trace what you're understanding and what you're not understanding in order to get the whole sequence of support courses and the pre-calculus course somewhat fine-tuned. Okay? You have to see this information. So there we have it. And you should be able to go on from there. All right. Up to this one. Here's your 2 to the x function, your basic exponential function, and the inverse. You don't have to know all this, just flow and base 2 of x. So if this is f of x, F inverse of x. Then we have 1/4, 1/2 fractions, not decimals. Stay away from the calculator. Okay, you need a calculator to do these because you're not looking at the rules of exponents. It's very simple. And you need the rules of exponents. So that's, you just can't function well in later parts of this course unless you know those rules. Okay, so there it is. So now we can draw a graph for both of these functions. I'll do that. And we've seen the graph. Again, when we do the graph of a basic function, the negative 2 plus 2, we subdivide this interval to get us negative 1 and 1. We subdivide this interval to get negative 1/2 and 1/2. Although we don't use negative 1/2 and 1/2 on this function because we can't calculate it exactly. You can't get that value without using the calculator. This is a no calculator exercise. Okay? So we exclude that from the domain of the basic exponential function. Then we need values up as high as 4. Well, let's make this a little more consistent in scale. So 4 is here, well, 2's here, 1's here, 1/2 is here, 1/4 is here. I'm not going to let this. Question of time. A lot of people got a really pretty good looking graph here. And then that's our basic exponential function, just those 5 points. Remember that terminology, because I want you to know that too, because I want you to learn to distinguish terminology, okay? And that's an easy one to distinguish. The extended basic exponential function starts here and ends here. That's it. Now the complete basic exponential function just keeps going this way and keeps getting closer to the x-axis. And pretty soon it just merges with the line of the x-axis, even though it really isn't on the x-axis. Any line you draw has a thickness, and this line will be within the thickness of this one. Okay. And that keeps going here. It keeps getting steeper and steeper. It gets twice as steep, essentially, every time you increase by a number. If I did the slope from here to here, I get a slope of 1. Slope from here to here is 2. Okay. The slope from here to the next would be 4. It gets really steep already. Then the slope would be 8, and then 16, and so forth. That's kind of important to understand. I'm just kind of foreshadowing that. You don't have to necessarily know that at this moment. But there's something, if you understand it, you ought to think about it for a second. Okay, so there it is. And then if I do the graph of the inverse function, of course, now I'm going to need to go down to -2 here, which would be about here. And here's -1, and here's -1/2, and -1/4, although we don't need those. Okay. When x is 1/4, we get y equals -2. Well, I don't even have 1/4 in this graph yet, but if I go halfway from 0 to 2, there's my 1/4. Comes down here and we got a point that's right about here. And when x is 1/2, we get -1. Well, -1 here, 1/2 is here, we get a point. And then when x is 1, y is 0, then we have 2, 1. And then I didn't really leave myself room. It goes off the edge of the page, but we'll just kind of plug it. 4, 2 is going to be up here. We're not going to quite get to it, but we'll get fairly close. So the graph goes on like this. Okay. There it is. Now you should be able to do it just as quickly as I did, because you don't have to explain it while you're doing it. You don't have to stop to explain anything. You should be able to do these tables, do these graphs in a minute. Time yourself. Okay. Because of course you to think about things. Okay, well, now there's some properties, line of symmetry, but I don't have equal scales, so I'm not going to bother with that right now. But I ask you to estimate the value of the inverse function when x equals 2. And well, when x equals 2, here's your graph point. Equals 2. And you can see that that comes over to y equals 1. Sorry. Now, I really kind of messed that graph up. I have to careless, but that's decent. I put this point up where x is 2. Probably should have labeled my axis so we've done it right. Get rid of a lot of this stuff. A little sloppy. And I do apologize, but we have 2, 1. Okay, 1 is here. And 4, 2, well, x equals 2 goes out here. So this graph levels off a lot more quickly than I showed it. And it's not particularly accurate now, but there it is. Okay. So when x equals 2, the graph point for x equals 2 is here. And it comes over to y equals 1. So our estimate y equals 1 when x equals 2, and that's actually the value in our table. So that's not even an estimate. This is actually accurate. Okay, now if x equals 3, well, if 1's here and 2's here, then 3 is about here. We can make that estimate. I'll use a different color. Green doesn't go great with purple, but at least it contrasts with it. And my 3 should maybe be over a little bit more, but it's not, it's a hand-drawn graph, so then just with what I got. So I need to sketch a projection line over here. This is the x equals 3 point, and we see that y is between 1 here and 2 here. It looks like y is approximately a little less than halfway between 1 and 2, so it's approximately 1.4, which is actually fairly accurate. Okay. If you estimated 1.3 or 1.5 because of the way you drew the graph, well, not judging your artistry, but we do want the graph to be reasonably representative, right? You don't want to be too far off. But with a decent effort on a hand-drawn graph, you can estimate this within 0.1. Okay. So y equals 1.4 when x equals 3, that is, f inverse of 3 is about 1.4. Or even, if you know the name of the function, log base 2 of 3 is approximately 1.4. And your calculator is not going to do you any good with this graph, okay, with these estimates. You don't know how to verify them. There are rules for logarithms that we'll see in a couple of weeks, few weeks. Probably close to spring break, either before or after, I'm not sure. So, this is important. Okay. Now, finding inverse functions. Okay. So you got y equals 5x minus 9. Actually, I'm going to say, let's say y equals 8x minus 9. Most of you didn't have an 8 in your equation. Okay. If you did, you probably didn't have a negative 9. Switch x and y and solve for y. If your algebra isn't there, we went over it last time. I recommended that you get to the mark if you can't do this algebra, and some of you really need some help, and some of you are doing pretty well with it, okay? You're doing real well with it, okay? You've got to be able to do this algebra, and we can't teach you how to do this algebra in this course. You just have to know it, go to the mark, get the help, they can work with you, and make sure you got the rules straight. Because as I say, there are plenty of people who are having trouble with the algebra but know how to do everything else. So you got the picture. You don't have the algebra, you gotta get the algebra. Okay, so switch x and y. We solve for y. Yep. Switch x and y, we get x equals 8, y minus 9. Solve for y, we get x plus 9 equals 8y minus 9 plus 9. So we get x plus 9 equals 8y. Then we divide both sides by 8. You don't subtract 8 to get y, you divide by 8. Please, everybody get your mask up over your nose. This wave of pandemic is receding. We want it to continue to recede. It's still out there. In a month, it'll probably be mostly gone. We can relax maybe. Okay, so 8 plus y is 8y. Then we divide both sides by 8. And I said 8, sorry, what is 8? X plus 9 over 8 equals 8y divided by 8. And I'll spread out to the side here. As I've done a number of times, this is why dividing by 8 gives you y. Because of the rules of fractions, which you absolutely have to know. Rational functions are coming up fairly soon. You can't deal with rational functions if you can't deal with fractions, because they're just fractions on steroids. You have to know the rules. Okay. Also, x plus 9 over 8, there's a distributive law, and you get y equals x over 8 plus 9 over 8. And there's your solution. Okay. Now, for purposes of time, we've got not even quite a half hour left. I'm going to kind of abbreviate this one. Let's see if I can squeeze it in right here. Okay. This is going to give you, well, y equals x over 8x plus 9. Just using my numbers from over here, plus on the 9. Doesn't make much difference. Then we solve x equals y over 8y plus 9. This has a complication. We multiply both sides by 8y plus 9. I'm not going to write the details of that. So again, if you don't know that algebra, if it's not clear to you why this works, you really need to get some help. I multiply both sides by 8y plus 9, which gives me 8y plus 9 divided by the 8y plus 9 times y over 1, which gives me just y. And of course, over here, it's multiplied. Okay. Well, this gives me 8xy plus 9x equals y. Got to solve for y. Well, instinct ought to tell you, you better get all your y's on one side and your x's on the other. Now that's going to give you 8xy minus y equals 9x. You still have to solve for y. All your y's are over here. You also got an x here. At this point, very few people coming into pre-calculus class get much further. Okay? If algebra preparation in high schools and so forth was a little better, that wouldn't be a problem, and it really should be better. But of course, especially this year, we're dealing with COVID restrictions and so forth, and the whole COVID thing for the last 2 years. So people didn't quite get everything they needed, okay? So there's a very good chance you would have gotten it a little better if it had been for COVID. But you have to get it now. Okay, so this can be written as y multiplied by 8x minus 1 equals 9x. Okay, just factoring out the y. And now we got y where we can isolate it. So that y equals 9x over 8x minus 1. And there's our inverse function. Now that is a little tricky. Okay, even if you had good algebra background, even if algebra was taught at the level it was taught before COVID, you would typically have to see that. Typically have to be shown that. A few people would be able to get it, but most people coming into pre-calculus course would need a little help with it. Okay, so there it is. Now that's important because when you're tested, very likely, a problem of this nature is going to pop up. Okay. I'm finding that the videos aren't getting looked at. Okay. I've told you that if you click through the videos, you'll recognize things that you might have forgotten since class, and you'll reinforce things that you need to know. Don't expect you to sit there and watch every word of a 30 or 40-minute video every time we have a class, because you've already probably done a lot of it, okay? But you want to review what we did in class. You don't want to rely just on open math, because I don't find that people that rely just on open math really get everything they need to get, okay? Some people do. But if you can't come in here and pass quizzes based on what you should have done in open math, it means you really need to be able to, you really need to probably look at the videos, click through them, focus on the parts that you didn't totally understand. I throw a lot of stuff in here that would be very helpful to you as we go forward. Okay? It's not a requirement, but it's a strong recommendation. You will do better if you do that. It keeps your synapses firing until you, and then when you do the open math, you have a bigger perspective. Okay. Of course, you do the open math immediately after class, that helps, but you should still click through these videos. Only takes 5 minutes if you understood everything, and if you didn't, you probably need to spend just a little more time on them. But you don't need to spend an hour on the things unless there's something you really don't understand. Okay. And of course, if you really don't understand it, it's probably going to come up in the quiz, and probably going to talk about it again in class. But in the meantime, you didn't do all that well in the quiz. Okay. Now we want to talk about linear functions. I don't think should even be part of this course. It should be something you already know for prerequisite courses, okay? But especially during COVID year, well, so be it. But it's really pretty easy if you understand a few things. Okay. Now let me just ask real quickly, we talked about fundamental triangles in this course. We have in the MDE, but have we done it? Because we've done quite a bit with linear functions in the MDE, so people who are in the MDE will be pretty well prepared for it, okay? But if we talked about it, those of you who are in this class but not the MDE, have you heard that term? I don't think we've done it. Just want to make sure I'm not repeating myself, okay? Yeah, I'd still repeat, but I'd repeat a little faster. Okay, so linear functions. linear function, unlike the basic functions which have curved graphs of the many types, this one has a straight line graph, which makes it really simple. Now, when I say it's really simple, yeah, it is, but you still have to know some things, okay? The linear function. Y versus X graph is a straight line. The slope M passing through the point 0b, and this point is called the y-intercept. So you'll immediately say, let's find the equation. The straight line through point 5, 9. So 1/2. Okay. Well, what do you know? Y equals mx plus b, right? M equals 1/2. And y equals 9. And x equals 5. This is what we know. It's what we know from what we said here. What we know is this. Yeah, just to cross out what I wrote, but what we know is here. Okay, so we can write it. M is 1/2, so y is 1/2 x plus b, right? And y is 9 when x is 5. So y is 9 when x is 5. Okay. And all we did here was we put the 9 in for y, and the 5 in for x, which gave us this. Now, that should be very clear. Whether it's clear or not, that's what you do. So if you just got to do it, but try to understand why you do it. Okay, it's because the equation is this. If it's a straight line, the equation has to have the equation for the function is one that is equivalent to this. Okay. So there it is. Okay. Now, having done that, how are we going to get the equation? Well, it's 1/2 x plus b. What else do we need to get the equation for y in terms of x? We need to know what b is, right? How are we going to find b? Any suggestions? Let me just pause for a second, see if anybody has a good suggestion about what we do to find b. Okay, so this will be, well, I'm going to say we do this. We do 2 times 9 equals 2 times 1/2 times 5 plus 2 times b. Now, what basic principle of problem solving or equation solving did I use there? 2 times 9, you will agree, is 18. 2 times 1/2 is 1, right? So this is 1 times 5 plus, is it 2b or is it not to be? Okay, so we have this, right? So that 18 equals 5 plus 2b. Why is this equation prettier than this equation? Because it doesn't have any denominators. So one basic principle of problem solving that you really want to follow, it's going to be really important as we go through chapter 3, okay, is that we really hate denominators. We really hate to work with fractions. And that's true for most of us, okay? Now, I don't really hate to work with fractions. I've got a student in my MDE 60 class who prefers to work with fractions and does it well. Okay, that's great. Okay, if you're good at using fractions, that's a really good thing. Because it means you understand certain principles and so forth that you can transfer, and you're going to understand other things if you understand those principles. But not everybody is good with fractions, especially since the schools don't do a good job of teaching. Teaching for the 5th grade, and then you put a calculator in your hand. Nobody ever works with fractions again. They just use a calculator. That's an exaggeration, but that people don't do enough stuff with fractions, so they come out almost incompetent with fractions. And you can't stay incompetent with fractions if you are incompetent with fractions. Not everybody is. Okay, so, and don't be insulted because I say incompetent with fractions. You can fix that in an hour if you really attend to it. Or if it takes you a little longer, well, you know, go to the mark and get some help. But I have assignments that run you through it. Okay, you've had them in this course. Okay, and if you didn't get it from that, maybe you need to go back and look at those. Still don't have it. You might need to get some help. Okay, so we have this equation. We multiply both sides by 2 because we've got a denominator, and we don't like to work with fractions, so we get rid of the denominator. Even if you like to work with fractions, you're less likely to make a mistake if you clear them out. It's just simpler. Now this is very easy. So we get 18 minus 5 is 5 plus 2b minus 5. So we get 13 equals 2b. So 2b divided by 2 equals 13 divided by 2. B equals 13 halves, which is 6.5. I'm not sure that fits well with my coordinates. Yeah, it works. Okay. Little brain freeze there. Okay. So now our equation. Y equals 1/2 x plus 13 halves. Now, can we graph the equation? Well, sketch me a set of coordinate axes and see what your graph looks like. You don't have to worry about the slope 1/2 anymore because you know that when x equals 0, y equals 6.5, right? That gives you a point on your graph. X is 0, y is 6.5. remember that goes back to this fact. That whatever B is, you have the point 0B. And also you got the point 5,9. So eventually you can put those 2 points on a set of coordinate axes and draw a line through them. Okay? I'm pretty confident everybody can do that. So let's make sure. It'll take a second. Don't mark off 50 points on the x-axis and 70 points on the y-axis. Draw a set of coordinate axes. Put 5,9 where you think it ought to be. Put 0, 6.5 where you think it ought to be, and draw a line through it. Okay? Okay, now I said don't line off a bunch of points in your x-axis and y-axis, but a lot of you just can't help yourself because maybe that's the way your brain works, meticulous, and that's not a bad thing. Okay? But we're not going to take class time to do that. Okay? We're going to do this. Now, my shoulders had 2 surgeries. It's locked into my scapula. So I don't know if I can throw this thing straight or not, but yeah, there's my 0.59. Okay. That's all I need to do. Now I've got my scale because I know that this is 5 and this is 9. Okay. And from that, I can line off all the points I want to. So if this is 5, well, then I'm going to conjecture that 4 is maybe here. And I can divide 4 in half and divide that in half and divide it in half there, and I've got my scale. Okay. And 9, well, I can put 8 here. That's about right, don't you think? So that would be 8. And I can divide that in half, and divide that in half, divide that in half, and that, and that, and that. As you've seen me do a number of times, the basic graph. And now I've got a scale. I don't have to put the numbers on it. I can count. Okay. Now, if I've got too many points, I might put numbers in a few of these. If you really want, you know, I'll put 2 here. And I'll put 4 here. And I'll even put 2 here. And I'll even put 6 here. Why not? Okay. So that's how you do a graph quickly. And that's what we want to do when I ask you to do a quick graph in class. Okay. You don't have to throw a piece of chalk at it. But my point is, you put it anywhere in the first quadrant. All I had to do was hit in the first quadrant. I wasn't sure it was going to work because I never know how my shoulder is going to stay. Okay. And I'm not warmed up. If I'm warmed up, I can get a little bit of accuracy, and no speed or distance. Okay, so there's our 0.59, and our point 0B is 0, 6.5. So just to distinguish things from white marks, there's 6.5, right? That's 0, 13 halves, or 0, 6.5. Now, this way to draw a straight line is to get yourself lined up and then look at the point you're aiming at. And I still missed, but not too bad. So there's my line. There's my line, y equals mx plus b. And you know, a lot of times you get a fraction here, you don't really know how big that fraction is. It doesn't hurt to write it as a mixed number. But if you're doing calculations with it, you're going to want to do calculations with the fraction. Okay, not a mixed number. Not usually. Okay. So you okay with that idea? All right. I think I don't have any more clean boards. Well, I'm gonna, oh, yeah. Okay. Okay, I want a line through -3, -2, and 7, 14. Now, we just went over this in one of my other classes. And everybody did their homework by formulas they saw in open math. Okay? And didn't understand a thing about what they did, even though I showed them what everything meant. Okay? You need to sketch pictures and fundamental triangles when you're solving a problem of this nature. Because it tells you what you're doing and it gives you insight that you're going to need later when you're dealing with other aspects of functions. Okay? So do this. Draw the graph. You slap down a point for 7, 14. And I know that 8 is about here, and 4 is about here, and 2 is about here, and -2 would be about here, and -4 would be about here, equal distances, so that -3 would be about here. And then if this is 14, that means 16 is about here. 8 would be about halfway down here. 4 would be about here. 2 would be about here. 1 would be about here. So that 3 would be about here, and -3 would be about that far down. So there's -3. So my point -3, -2 is about here. And that's a good thing if you're clicking through, you know, and understand what I just did. Look at it again. Read my words. Listen to my words. Look at what I've done. Okay, and up here 14, well, there's 8, so here would be 12, and halfway between 12 and 16 is 14. So 16 should have been a little higher, so I'm going to use 7, 14 down here. Okay. And then I'm going to draw a straight line. Okay. There's my line. I can estimate. What do you estimate the y-intercept? Show me with your fingers. What do you think the y-intercept is? Yeah, you use fingers on just one hand, because if you use fingers on each hand, you might make an improper gesture. Okay. Okay, well, if you look at it, if this is 8, this is 4, I don't know if you can read my writing. It goes right through 0, 2, right? Okay, so it looks like now I don't expect that's accurate because it's based on my drawing. Okay, but I don't think it's too far off. We'll find out. Okay, well, we've got 2 points on the line. We just saw how to get the equation of a line if you've got 1 point in the slope, right? So now we should be able to get the slope. It's actually easy to get the slope. Okay, but before we do, I want to see if you are familiar with the terminology. Okay, so what's a slope? Well, first, maybe. Probably not, but something probably close to that, right? And the picture tells us what's going on. The formulas don't tell us a thing about what's going on. Now, if you don't really know how to use the formulas, okay, but it's much easier to know how to use the formulas. You see what's going on. Otherwise, you're just using formulas out there in the ozone and you don't understand what you're seeing. Okay, so that's why we draw these pictures. Please don't do what classes usually do and just go back and do the formulas because it's easier and you have them right there in front of you. You won't learn it. I mean, yeah, if your background is good enough and you're smart enough, maybe you will, but most people will not. Okay. So maybe y equals mx plus 2, we don't know. Okay, what about the slope? Well, slope is rise divided by run. You've got 2 points here. Can you tell me what the rise is between these points? Actually, can you tell me what the run is between those points? Because you do that with your fingers. The rise takes more than 2 hands. You'd have to use teamwork. Okay? After an MDE, we could prove this, right? And if you have trouble with this, you might go back. I post the MDE videos, good. Post the MDE videos, all of them from MDE 60 and MDE 61, along with the videos in this course. They're all there in Canvas. Okay? With some titles to kind of tell you what you might be looking at. Take through some of those videos and see what's going on. Okay? If you really don't understand, it's pretty well developed in detail in those courses. Okay? And that's available to you. I'd be an even more terrible person than I am if I didn't make those available. Okay, so the run is 10. How did you get that? Well, the run is how far you got to go in this direction to get from here to here. And the rise is how far you got to go in this direction. You can see the rise from -3 up to 14. From -2 up to 14, you got to go 16 units, right? And from -3 up to 7, that's in this direction, you got to go 10 units, and some are certainly that. Okay. To aid in visualizing what this means, I draw this fundamental triangle between these 2 points. The hypotenuse goes from one point to the other. The run goes horizontally. The rise goes vertically. So that we have a path from one point to the other along 2 line segments that make a right angle because one of them is parallel to the x-axis, the other is parallel to the y-axis. This triangle is very important. It can be used to find the distance between these points, which is an important quantity. Okay, but right now we're just dealing with slope. Okay, so the run is the x-coordinate we end at, which is 7, and minus the x-coordinate we start at, which is -3. Now, we want to keep track of where we start and end, so we put little arrows on these 3 segments, so that the arrows always take us from one point to the other, starting at the same point, ending at the same point. So we don't want an arrow going this way and then arrows going this way and this way, because that takes us the wrong way. Okay, so if we go this way, we subtract where we start from where we end. So that's 14 minus -2, where we end minus where we start, which is 14 minus 2, looking at the wrong numbers. Okay, again, it's 7 minus -3. Which is 10. The rise is 14 minus -2, which is 16. So the slope equals rise divided by run equals 16 over 10, which of course is 8 over 5. And I put that here in a box next to the hypotenuse. Now, when you do these, I want you to do them exactly as I did, right, labeling everything with the arrows, everything that I just did. If you do that, you'll understand slope better, and you'll be able to do it when we have symbols involved. There's formulas in the book that bypass understanding, okay, and they can actually be used to build understanding, but probably not, okay? Now we know what the equation is. Well, we don't really, we know that, okay, so y equals mx plus b, m equals 8/5, and y equals, we can pick the coordinates at either point. It doesn't matter, we get the same result. So these numbers are smaller, but they're negative. So I'm going to stick with positive numbers, but that's a matter of taste. I would probably go with the smaller negative numbers, but y equals 14 and x equals 7. Okay. And we think b is about 2, but we're going to check that. We're going to test that. So what do? We do just what we did over here. You just do what we did before. We write 14 equals 8/5 x, 8/5 of x, but x is 7, plus b, and I've just got to see if 2 is right. Hang with me for 30 more seconds. And multiplying by 5, we're going to get 70 equals 56 plus 5b. So that 5b equals 14 and b equals 14/5, which is actually 2 and 4/5. So yeah, 2 is not bad, but is actually this. So now we can write our equation. Y equals 8/5 x plus 14/5. Or if you want 1.6x plus 2.8, 2 4/5, you could do that. So all this is this equation, and we can check it by plugging in 7 for x to see if we get 14 for y. And we can check it also by plugging in -3 for x and seeing if y ends up as -2. I did that fast. I could have made a mistake. You could easily check it. If you happen to be clicking through this video, it's not a bad idea to just jot that up. Should be able to do it in a minute. Okay. But if you totally understand it, it's not necessary.